Let's start. It's time 1:32. So you've got in your calculator, I want you to try a few things. So just like we have our use case here, 22 plus 23 equal to, or any two numbers you add, you get the result. And then what happens if you start typing more digits? Just appends, right? How do we fix that?
We should change the starting number.
Exactly. And where do we do that? Here. Exactly. So in your case, equal to where the computation has been done and now we are displaying the result in our text view, you want to tell this controller, the main activity.java, that any new digits, they are a part of a new calculation. So they are a new number altogether. So that's what we'll do here. We'll say start new number So now once you add this line, what will happen is now you add two numbers and then you start typing another number. It will replace whatever is there. Okay. I think at this point we should implement the clear button, because otherwise to test becomes more difficult. You have to keep restarting the app all the time. So let's implement the clear button. How do we do that? So how do we do that? First thing, we add a case to trap the clear event. Whatever you have used as the text for your clear button is what this case is going to look for. So, for example, I know that some of you have done it slightly differently, and that is absolutely fine. Mine says just a C. I saw somebody had AC, all clear. You know, whatever you have used, the text, that is the text you're going to add in the case. So, and case is case sensitive. I'll add a break right away so that it doesn't go past this. And this is where we want to tell the model. What do we have to tell the model now when C is pressed? Set everything actually in this model. All of this should come back to this, because these may have been true. These have been set as, you know, some other numbers. So that's what we want. We want to reset this, right? Or clear. Let's stick with that terminology. So we'll add a function here, and let me add it to the bottom. All our new functions, we'll add it to the bottom. Clear. So what it will do is it will set the first number set to false, and first number itself will set to the default. Actually, we don't even have to set this, but it's okay. Let's just be more diligent. What else is there? We have operator result and operator set. Everything, all these values. So Ravinder, Jagir, we added this line in our case equal to, make sure you have the start number equal to new. And now we are implementing the case for the clear button. So for that, we have added a method here in the model called clear, which will basically clear all the values. So this is what we are going to call here. So call that method here. And see if it's working. Is it clear? It doesn't clear the display, right? Because we haven't cleared the display. We only cleared the model. So how do we clear the display? We have to set this current number string and start new number to true. So that's what two things we need to do. Current number, whatever we want it to show there, if we're showing a decimal or not, it's up to us. And start new numbers should be set to true. Now your calculator will allow you to clear and do more than one calculation without having to reinstall the app on your emulator or your phone. Okay, so we got that part. So our calculator has grown up a bit. We can add. Let's teach it to subtract. How do we do that? What are the things we need to do in terms of coding? So now, see, now we are looking at a different use case, right? Let's, instead of plus, I'm going to put a minus. So when the minus is pressed, does our code do anything right now? If you can try 22 minus 33 and see what happens. Just say 2233 because minus is completely ignored. We did something for the plus. So all those steps we need to repeat for the minus. So what was the first step? Case. So here the question for us is, we have a case for plus, right? But this case, if you notice, it is completely agnostic to what operator was there. It might as well be minus, it might be anything. So all we have to do here is, we just have to say case minus. So for both plus and minus, it will execute those lines of code. Okay, but in our model, what happens? This is our model here. We have a what do we need to do here? So we add a Add a case, right? So why don't you all go ahead and do it? Add a case for the minus, compute the result, and then try in your calculator. Just to say something. So when you add a new case, you don't have to keep on indenting. Like if after this line break, watch the screen, what happens. I'm not backspacing, nothing. I'll just say case and I'll put a minus, and as soon as I press the colon, you will see it shifts automatically. I don't have to do anything. So this, all the code formatting will happen automatically as long as you let it do that. Working? So now I'll add the lines here as well. So I'll just copy the lines, and when you copy and paste, you have to remember to change what you need to change. So that's how easy it was. We added how many lines of code? 1 line here and 3 lines here. 4 lines of code, and now our calculator can do subtractions as well. Okay, so go ahead and do the other two, multiplication and division. one thing you have to watch out for is make sure that if you have used whatever characters you have used on the keyboard, you use them in your case statements. For example, if you have used star for multiplication, in your code should also be star. If you used an X, it should also be X. Okay, you got the all four operations. So those who've got all four operations, try things like this. And then whatever result you get, try this. See if this sequence works. So some quirks of Android. Aniket noticed that even though in the calculator app, when you run it, if you have any text, it shows up all capitals. So you may think that you have typed it all capitals. But even if you type it in a lowercase, Android capitalizes it. And I'll give you an example here, right here. See, the text on my multiplication button is a small x, and here it is showing up as a capital X. So my code, and I thought, I remember using a small x, but I saw a capital X, so I just used a capital X here in the case. It's not going to work. So that is something you need to be aware of. If you are seeing behavior that is unexpected, watch out for that. Okay, so series of operations. Has anyone tried it? You have to press an equal to between two operations, right? If you do a plus b minus c without pressing equal to, what happens? Just does the minus part, right? So let me just try this. 10 plus 2. So it keeps on replacing. I did 10 plus 2. Let's try this. I'm expecting a 1. What do you get if you do this? Since we are all running the same code, we should get the same results. We should get 10 plus 2 minus 7. We should get, oh sorry, my mistake, 5. Thank you. But we are getting minus 5. What it's doing is just this. Because what it's doing is every time an operator is pressed, we take whatever is in the current number and set it as first number. So it just has no memory of a 10 ever being there. It's just, you can keep on doing it, it will just do the last two, whatever was the last operation. Forget about everything else. How should we fix this? What do we want now? See, what should we do now? It's telling us, I can just sit here and you can let it talk. The lady from Google knows everything. So what should happen in this case? So our sequence is 10 was pressed, then plus, then 2. Right? At this point, what do we want?
We want the result assigned to the
Exactly. So as soon as another operator is pressed, we need to treat it as if an equal to and a minus both were pressed. Otherwise, we'll lose one of those two. Either we'll lose the result or we'll lose the minus. So we need to do both. So in this case where we are looking at the operators, we need to figure out if the model has the ability to compute a result. If it has, then we get the result and set that as the first number, and the operator is what was just pressed. So now then, over here, what is the sequence of events? First thing we check. We need to check. Actually, there is more than one thing that needs to happen. At this point, let's do this here. It's easier to see things if we just follow them here. So we pressed 10 and then pressed plus. So the first number became 10 and the operator became plus. Then we typed another number, let's say 2, whatever number it is. And then we pressed a minus. At this point, there is no second number here either. So how can it compute? So the model doesn't know the second number. So here what we want to happen is that this number, when the minus was pressed, we need to check if there is a second number or not. If it is not there, we assign it. We don't assign it to the first number, we assign it to the second number, and whatever is the result, in this case 10 plus 2, 12, we will assign it back to the first number, and the operator will change from plus to minus. All of this needs to happen. Okay? So, we can define functions to get the values of these, the booleans, or we can just call it here. So for example, here the first thing I want to check is whether there is a second number or not. There is a first number and there is an operator, but there is no second number. Then we need to set that and then compute the result. So let's check that. If calculator model dot first number and I'm sorry, this should be first number set. And operator set. So if the operator and first number are both available, then we'll do this. What will we do? We will parse the double. We'll do all of this basically, but we'll do it to the second number. Okay, so we get the second number. We are going to assign it to the model. Okay. And now we know that first number and operator are there. We are going to do a get result. So this is what we need to do. We have assigned the second number, calculator.second number, we get the result. Actually all of this, I could have just copied these lines of code here. Or we could put them in another function. Code reuse is a good idea. If you have the exact same code in two places, it's better to create a function out of it and call that. So this is an ideal candidate for that. These 4 lines, they're identical to these 4 lines. Okay. So this gives us what we need. See, what has this done? So if we follow the sequence, when the second time this minus was pressed, we are checking if first number and operator are available. That's the condition in the if, inside the if. If they are available, then we calculate, we take whatever was on display at that time, which was the 2 when minus was pressed. We take that that becomes our second number. So this current number had 2 at the time, that becomes our second number. Then we set the model, in the model, the second number as 2. So now, before that it had 10 in plus, now it has the 2. So it can compute the result. So we get the result, it will compute the result when we call result equal to this. No, I'm missing one more thing. No, I'm calling the get result from here. So yes, get result function computes the result and returns it. So it came back with a 12 and I updated the current number with that. So when we are done with this function, at the end we say show in the display whatever is the current number, which has become 12 now. So it will show 12 and then it will do all of this. It will set that current number as the first number. Here, see, it will set this current number became 12, right? So in the model, that number becomes the first number. The operator becomes button text, which is the minus now this time. And start new number becomes true. So now, with this in place, you should be able to do A plus B minus C and actually keep on doing it. Because every time it's just replacing the first number with the result. So if you have even more than 3 numbers, a series of more than 3 numbers, you're adding, subtracting, multiplying, dividing, whatever it is, it will keep on doing them and keep on updating the model. Is it working if you try? Working, right? So gradually, if you watch, our process has been gradual. We have been finding things to keep on improving and we are adding a little bit at a time. We are almost at a calculator that is, there may still be quirks. So at this point, the calculator has grown up a little more. It can does all 4 operations and it can even do a series of operations. So why don't you guys play around with it and find problems with it? Yes. It does not follow? Sorry, what is that? Ah, okay. The operator precedence. Yeah. In the classical calculator, let's try that. Here, Microsoft has given us one, and on your Mac also, if you open the calculator app, it will give you by default exactly what we are trying to do. Okay, so let me see, 10 plus 2, right? And now I press minus, I'll see 12, 7. Okay, so give me an example of the rule that you wanted to follow.
I do 6 plus 3.
Right? And you are expecting to happen first, right? So it should give you 24. No, it's 30. But it's going to give you 9 times 8. Yeah. That is a problem. So let's see what this one does. This one probably will do the right thing. No. So our calculator is behaving like a classical. You are right, it doesn't. It's behaving like a, and that was what our aim was. If we want it to follow, then this model is not sufficient. then we need to be storing multiple, first, second, third, fourth, whatever, because the precedence, we don't know how many we will need before we can come back and calculate. Or we need recursive models. The model needs to hold an object of its own type, so it can do calculations and return results and all that. Okay, what other problems? Play around with it. Yeah. Doesn't support division by zeros. So if we right now, I'm installing on my phone, I'm just going to type a number and divide it by 0. Okay. I seem to have a bug anyway. It's not even doing any divisions. What happens when you say divide by 0? It says infinity there. Okay. Which is actually correct. Right? No, but it is infinity, right? If you divide any number by 0. Oh, okay. Okay. I see what you mean. So if we want to do that, let's open here. So 5 divided by 0 cannot divide by 0. It's giving an error. So infinity is fine. I think it's okay because it's more accurate than 0. If there was somebody who doesn't know division by 0 gives infinity, they may think, okay, it is anything divided by 0 is 0. So it's okay. I think we'll accept it. Yeah. What else is... Yes, Janisha. So that behavior is okay if you are pressing equal to repeatedly. You are just pressing plus. Okay, so she's found a good one. In your calculator, if you type any number, let's stick with that example. 10 plus 2. And now if I press plus, it gives me 12, right? If I press plus again, it keeps adding it. So at that point, how do we fix that? So basically what happened was, this is the sequence. 10 plus 2 and then plus. We don't want it to do anything. We just want it to record that the operator was updated. Right? How can we do that? What is our problem? Why is it calculating? So what it is doing is, see, first time I had 10 plus 2 and then I press plus, it gives me 12. Up to that point is okay. When I press again any operator, that point it should not do any more calculations, right? It should just set the operator and do nothing else. Set the first number and the operator. So we need something here. We need to stop it from doing this to compute another result. How do we know? What is it here that we can use? How about this? See, we set the start new number to true. what if we add a condition here that this must be false, that it is not so what it will do now is we have typed a number, we did 10 plus 2 and then we press the plus. So when that second plus was pressed, we were already typing a number. We had typed the 2. So start new number was false. It is accepting new digits. So this not start new number is true. It will do the calculation. It will put the result. And then it will go outside this if and it will do, set the result as the first number and set the operator. And then set start new number to true. So when start new number is true, the second time, in this sequence, this second plus, it will come into this if block and say, okay, is my first number set? Yes. Is the operator set? Yes. Am I expecting a new number? Yes. So not start new number will become false. It won't go into this if. Does it fix it? It fixed it, right? Any other problems you can find? Try play around with, do things that it is not expecting you to do. Press the equal to repeatedly. Press multiple operators in sequence. Use the decimal. Yes.
After doing calculation, when I press the clear button, and then start doing the calculation again, I have to minus something. Okay, so what's happening on the map? Yeah.
Sequence again, someone else doing their calculator. So try this. So as you're doing it, just tell someone that what you're doing to do the exact same thing. And we see if it's a universal problem or localized. Just started it.
Started the program.
So look here.
So the problem
Clear. How you need to set all the videos of the walls. How so this is the you found it. So this Okay. So what happens if you repeatedly press equal to? It keeps repeating the operation, right? That's the expected behavior actually. Here if I say 5 plus 3 and then I say equal to, right? And if I say equal to again, it will add the number to it again and again. So that is, it is repeating the operation. Okay. How about the look? When we say 2 plus 2 equal to, what does the display say? No. What does it say? Exactly what does it say? Yeah. 4.0. Right? It's not saying it's. That is not how the calculator works. See, here we are working with integers. It does not bother showing the dot 0. How can we fix that? How can we? We can convert it to an integer conditionally, right? Not always. If it's not an integer, if it's, if you do 1.1 plus 2.2, if it is 0.0, right? So if it is basically an integer, we display the integer. If it's a decimal number, it will automatically pick up. Try a decimal number and see how many places of decimal it shows. It does something funny actually. I just did 1.1 plus 2.2 and it went 3.3 and then in lots of zeros and then a 3. It's a huge number. So let's fix the first part. Let's say when there is dot 0, we don't want it to show the dot 0. How do we do that? Where is it happening actually? Where are we setting that what is being displayed? So here everything is in double, right? The problem is when we convert it to a string, because what we are displaying there is a string, it's not a double. So that is the point where we have to trap it. The double can hold whatever value it wants to hold, let it hold that. We don't really care. But what we want is, when we are displaying it, this is where we are doing it. See, let's look at the equal to case first. We are doing double dot to string get result. Okay. Now, if we want that it, instead of just converting it to a string and showing 4.0 instead of showing just 4 dot or whatever our convention is, we can implement a function. Let's do that. And this will return a string. Let's call it results to string. And this will take a double. So how do we know if a number that is a double is also an integer?
In JavaScript, we actually have some function called tab on and check the variable tab. I don't know if you Java the similar.
So we here what we know is this, see this double, right? Let's for the sake of the argument here say num is 4.0 and I want this string to show only 4. What we can do is we can convert the double into an integer and then compare the two numerical values if they are the same or they're within a tolerance. Because of what I saw here, lots of zeros, we could even go with a tolerance that if it's a very small difference then we treat it like an integer. But let's forget the tolerance. Let's just do that. Int okay, so this will convert the double into an integer. And if now we'll compare the two. If it is this, then instead of returning a double dot toString, we will say integer dot toString. So that way it is going to get rid of that dot 0. Otherwise, we will just do as we were doing before. We'll just return this double dot toString. Same thing. So this is a good trick. You can use it for other things also. For example, if you wanted to show a certain number of decimals, but in our case this should do it. Now we need to call this function. Call it from the two places where we are doing double dot toString, replace it with this. Here, so here instead of this, just call that function. Same thing here. Double dot toString, we say results toString. And now run your app and see if it shows that dot 0 again. I think I should show you the method again if you're still typing it. This was our method. working now? Okay. So it does not show the dot 0 unless there is actually decimal places. So if once you have typed this, replace the function call where we are doing this. Here it said double.toString in to convert the result, get result to string. Instead of that, you just say result to string. So, how many of you got it working? Show of hands, please. Okay. Good. So we'll wait for the others to catch up, and then this is more or less at a point where we've done. I think we are missing a couple of things. So there is another problem Reginald found. If you type a number and press equal to, what happens? What should happen?
Showing the number.
Just keep showing the number. Ignore the equal to altogether, right? So where do we fix it? In here. So this what do we need to check? So if when you press equal to, if you have not given it anything, you're just typing a number, right? So you have not even set the first number yet, right? So even the first number is not set. So all we need to do is check here if first number set. What if there is a first well, just checking first number enough, or do we need to check for an operator as well? So if we just say this much, yeah. Let's just put this in an if block. If first number is set, then only it does the calculation. Otherwise, it just ignores the equal to. See what happens now. It still says 0. Why is that? what is happening is there is a problem here. What is the problem? I made a mistake there in the code. What is my mistake? That's it, Hamza. Good job. Break is inside the if block. So what is happening is it comes to case equal to, this condition is not met, so it keeps on doing, but it thinks that it can do this because the break is inside the if. So this needs to be moved out. So little by little, the calculator is doing whatever we want it to do. Okay, what I want to do next is I want to go back to the presentation that we started with and just recap what we have done and tell you about what your assignment is going to be. It's going to be simple. It's not that difficult. Your assignment, let me tell you that first. These two question marks, I want you to replace them with two operators of your choice. Whatever, you are welcome to choose whatever you want to do with the number. Okay, and do that. So choose square and square root, just as an example. So if you press square, whatever is the number, it should square that number on display at that moment. Square root, the same thing. Or, the traditional calculator, what else does it have? The Microsoft calculator. You can take inspiration from this as well, like percent. What does percent do? 1 by x. Any of these. That is one job. And the other job, we did not implement this plus minus. We had this. You tried, it crashes, right? Because the case is not there. So implement these three things. That's your assignment. So two operators of your choice, and a third one that everyone will have to do is the plus minus. So plus minus, the expected functionality is that whatever is the number on display, when you press plus minus, that number changes its sign. If you keep on repeatedly pressing, it will toggle between positive and negative numbers. So that is your assignment. It's, as you saw, it was really easy to go from, plus to then we adding the three operations was literally like a few lines of code. So this should not be that difficult. I will post this on Blackboard. You will have a submission open. There will be some instructions as to how you will submit, what you will submit. So this is our this is what we started off doing today. We wanted basic arithmetic operations and then multiple, a series of numbers. We achieved that. So we designed the class, the model. So this was your glimpse into how to work with model view controller. So there is a very nice separation of the code logic. Your model class, the calculator model is doing all the things that the model is supposed to do. It knows first number, second number operation. It has no awareness of what it looks like in the view. You can go ahead and change the view. You can change all the buttons to something else. You can change the entire scheme. The model will still stay the same. And the controller is what talks to both of them. The controller has an instance of the model. That's how we started. We created an instance of the model. So every time something happens on the view, you press a button, you do something, the controller receives an event in this button clicked and it updates the model if needed. When you are typing digits, it does not keep updating. It just updates when you press plus or equal. So it is has some intelligence that way. And then when expected, it will get a result from the model and display it also. So all of that the controller is doing. And the view is just the view, the design we chose. So what's the name of the rule you said? How do you spell it? BODMAS, Bodmas rule. Okay. So that rule is about operator precedence. We saw that we don't deal with it, just like any other classical calculator. It will get too complex. If we start doing that, we will have to store lots of numbers. We'll have to pretend that there are brackets around certain numbers. Okay, sorry, this slide is incorrect. Actually, my presentation is incorrect altogether. That was for the iOS class. So this is for today, introduction. This is what we did. That's why I was wondering, there were a few extra slides in there. So we did this much. What about this part? Through this app in these two classes, this is the question. Change the device type in the layout editor. Let's try that. So we used what you saw. What was the name of the layout scheme we used? Constraint layout. Constraint layout allowed us to design this. Now, over here, I can change. I can say instead of a pixel of this dimension, I have got, let's say something with a slightly different aspect ratio. This one, pixel 3. It should auto adjust everything, regardless. And see, many of you are running it on your devices, and the devices are all different. So this same thing you can also do in the emulator, but this is as good. It tells you if I change this, it keeps on recomputing, laying out again and again. So this is in a tablet in landscape mode. So that's the beauty of this, the constraint layout. So that's the question we wanted to ask. Change the device type. Change orientation. The same device, I can change its orientation. So instead of it being portrait, I'll say landscape. And it should recompute everything and lay it out very nicely. Doesn't do it? It compresses them and the text disappears. Is that what's happening? Okay. So there is an issue with the constraints. See the text field is taking up a lot of space. So that needs to be adjusted, that constraint. So if it is not happening, then you have to examine your constraints and see if you have fixed its width. Instead of giving it a percentage, you've given it a fixed width in your portrait layout. So let me show you what may have happened. If I go back to portrait and I examine this, right, this particular, I want to look at its attributes. So where did the attribute window go? Okay, I don't seem to have the attributes. Okay, anyway, we'll just look at the XML here. See, layout height of this text view. If you have a fixed number here instead of it being something that can be computed, then your layout will have that thing as fixed. Let's say you say it's 100 pixels regardless of the device, regardless of the orientation. Then you have said that you want it to be 100 pixels. So you always want to work with either percentages Or things like wrap content. Wrap content, what it does is it takes whatever is the size of the text and fixes the width or height to that. Try on your phone. Those of you who have your phone, try it. Try to rotate the phone, see what happens. So this is our main objective. It was to create a consistent and professional look on all devices. Do you guys think that your app looks professional? If you compare it to a calculator app that you can download from the Play Store. It does? Or no? No? Huh? Okay. Yeah. So if you do all the coloring and the text size, it gets to that point where this is something you can put it on the App Store. So in other words, this is the buzzword, responsive. We don't have to design separately for so many years. Android has over 10,000 devices that it supports, 10,000 makes and models combined. So we just do it once and it works everywhere. So that was one thing we wanted to do. So this is what you will submit. You will submit the project folder and the APK. Now I don't know if this APK that it creates is a complete APK. In the sense, you know what Android does is you can find your APK, you can go into the apps and then build. I'll show you again. Let me just see if it has produced an APK. Okay, it just produces a debug APK. So, okay, I'll put this in the Blackboard, how to find this, what you have to submit. Okay, it's easier that way. So that is what you will be submitting. I might also, in the Blackboard assignment, I might ask you to submit screenshots. Makes it easier to see what has been done. Okay, so that is our more or less the calculator app that we started off in the last class. That was our objective to create, and that's what we have done. So I want to get some feedback from you guys. Like, what are the things you think we have learned so far in these 3 classes? Designing. So placing different widgets, yes. Constraint layout, how to create constraints so that it stretches and it compresses. MVC, model view controller. Java coding, we saw Kotlin very little, but Java is what we used more. Creating classes, etc. Event handling, how to handle events on buttons. How to customize the layout, changing the text, the colors, the spacing, the background, and all of that. There is a lot of things, and you know, there are other things that are hard to quantify that you will just learn from doing it. That, okay, this kind of error happened, and this is how I know what to do. Right? And the other one we did was thinking through the model. When you're given a problem, how to create a model that will be able to handle that problem. So break it down. That was the other thing we did. We broke down the calculator problem into smaller chunks. First, last week what we did was how to enter a number. Today, after we started developing a model, we said, okay, how to store that number somewhere, then how to add a second number. And then we just did the plus, one operation. Then we added the others. So like this is the general approach. So I want, this is like a survey, I want this question answered. How many of you felt that the topics covered over the last 2 weeks were of an appropriate level of challenge? Show of hands if you thought it was appropriate. Okay, most of you think it was appropriate. Who wants to make it harder? We will keep on ramping up. So the next thing we will do is different. I will tell you a little bit about what we are going to do next, and we'll end the class there. Next app we are going to develop will have more than one activity. So this was a single activity app. You had one screen, you were dealing with it. Next one will have multiple screens. So you go from one to the next. And what it is going to be is so imagine a program that shows a list, like a list of contacts, list of emails. If it's a list of contacts, you may have a plus or an add, whatever, plus button here in Android. This is more conventional. It opens a new activity that lets you add a new contact. You can add picture, phone number, address, whatever you want. And then it has a save button. And then it goes and gets added to this. And if it was already existing, you touch it, it opens the same thing, but the fields are pre-populated. You can edit it. So that's the kind of thing we are going to do. And we are going to do it with the help of a game. We are going to create a game. And this will be the history, game history. So what you will learn is how to store data internally that you can show a list. Right? You need to store it somewhere. And given some information, when you touch it, how do you know that you have to show a blank or pre-populate it? So that part also. And then in itself, this part, how to do this, how to have data going from here to here, all of this will be covered. That is going to be our next step. I think it will take us 3, maybe 4 classes, depending upon how fast we move. So, what game do you think we are going to do? It's a simple game. What was that? Mario, Super Mario. I think we'll need a few semesters to do something like that. So, how about a tic-tac-toe? How many of you know the game of tic-tac-toe? Yeah, so we'll do a tic-tac-toe. We'll develop the logic. Again, so it will involve creating a model. And so that is going to be our job. So we'll have a tic-tac-toe board. And the game history and everything, we'll do that. And then when we reproduce the game history, we'll see if we can show animation, what sequence the moves were played in. So we'll include a bit of animation as well. So that's going to be your next few classes. Okay. All right, I think it's 2:53. We'll stop here. Any questions? Okay, I will help you. Anybody else have any questions that could benefit the class? Okay. All right, see you next time.